Great. Thank you. Okay, we are going to, was there another wardrobe?
Well, I did a costume change, so I'm going to now provide all the shirts that have been given to me at all the
cons
and whatnot.
You had to actually have a Fairwinds shirt in your stash of shirts somewhere. I wonder how that worked out. But okay, so we're going to bring in our next presenter, who is also a Cube Crash alum and one of our favorites for sure. Stevie, thank you for joining us again. Thank you for suffering through us again. You've been such a trooper, and it's so great to see you again and have you back.
Thank you.
Do the Fairwinds talk.
Yeah, it's great to be here, and it's really great to see Danielle again, to see your face.
Awesome. So I'm going to add your screen share to the stage right now. It is, if I look backstage, it's sharing us. There we go. Just let me know when you're ready and I'll share it. There we go.
Right. It's looking good.
That ought to do it.
Stage. Beautiful. There you go. All right. Open us up with a joke.
intro. We were so happy to see you. We did not give you a proper intro, so please tell everybody who you are, where you're joining us from, and take it away. Thank you.
Actually, so I do have a funny joke that I was told recently. I think, oh crap, I'm gonna forget it, but it's something like you can only ran because it's past tense. Well, what can you do in a campground? You can only ran in a campground because it's past tense.
Oh my gosh. I get it.
That's the joke. Okay. It took me a while to get it.
Get it? See what she did there? You're running past tense. It's past tense. Okay. Yeah. Not that I have to explain that, but it took me a minute. That's pretty funny. Thank you for that.
You're welcome. I'm glad to share the corniness. So, hey, yeah, that's my company's intro slide. That's us. We're Fairwinds. That's our logo. We always start off with that. And who/what is Fairwinds? I'll tell you by reading our mission out loud. Fairwinds is the recognized leader for building, maintaining, and optimizing mission-critical Kubernetes infrastructure, enabling companies to accelerate their time to market and deploy applications confidently. So we do Kubernetes, and we're pretty darn good at it. We've been doing it for a while, and we have a lot of expertise in this area. So that's who Fairwinds is. And then that's me. I'm Stevie. I'm a senior technical lead at Fairwinds. A little bit about my background. I started off as a desktop support person, and then became a network engineer. Then became a sysadmin, mostly in the Windows realm of things. Then became a DevOps engineer, and started working with Linux. And then became an SRE and focused primarily on Kubernetes. And I've been working with Kubernetes for about 7 years or so. So I know a thing or two about Kubernetes as well, which is why Fairwinds is my home. So let's see. Today we're talking about building the ultimate internal developer platform. And this talk in particular is focused on reliability. And the tools that we're focused on for helping to achieve reliability in this case will be Goldilocks and Keda. So we'll start with looking at Goldilocks and what it is. So Goldilocks is open source software developed by us, Fairwinds, internally. It's a utility that can help you identify a starting point for resource requests and limits. And it essentially helps you just write your Kubernetes resources. It's one of our most popular projects. It's used by lots of folks that you would recognize, like Lowe's, NVIDIA, Epic Games, and my favorite bank to pronounce, Santander, also uses Goldilocks. And then we're also going to be talking about Keda. Keda is the Kubernetes event-driven autoscaling. It's a CNCF graduated project, and it expands on the HPA, the horizontal pod autoscaler. Allows you to scale to 0, scale off custom metrics, and things like that. So, I've just told you about these two projects, and you might be thinking like, yeah, and so how does this relate to reliability, Stevie? I don't get it. Well, if you've worked with Kubernetes, you've no doubt seen things like this. You've seen crash loop back off on your pods. You've seen exit code 137, and you've seen liveness probes fail, or readiness probes. They look the same way in the logs if you describe a pod. There are lots of potential reasons for a crash loop back off. You can have a misconfigured application, you can have image pull errors, but there is one common potential cause between all of these, and that is resources. It's related to resources. So resource starvation can cause crash loop back off. Exit code 137 is just point blank telling you that there is an issue with memory. And liveness probes and readiness probes can fail if there's a CPU resource contention, right? So, and the app can't respond to those probes in a timely manner. So, in the case of the liveness probe, it's going to restart your container. And in the case of the readiness probe, it's going to take your pod out of the endpoint for the service period, and no traffic will be routed to that pod for that time period. So, if you're a dev, it's one thing to troubleshoot applications that are having problems due to something in the code, right? Something at that level. It's a whole nother thing to waste cycles trying to troubleshoot things that kind of fall more along the infrastructure side of things. That becomes a pain point for people and for devs who just want to push their container out to something and watch it work, and then do their work and iterate on features and things like that. So if we're talking about resource contention and how it can cause instability that can be frustrating, we can make the connection to why tools like Goldilocks and Keda can be useful for mitigating some of these things, because they work under the hood with scaling. So scaling, two things. It gives applications proper resources to make them less susceptible to memory issues or CPU throttling. And they can also increase the number of replicas that you have for your workload to also alleviate some of that stress and mitigate that pain point to an extent. And so Goldilocks works with VPAs, the vertical pod autoscaler, and Keda works with HPAs, the horizontal pod autoscaler. And they can work together in a pretty nice little dance of like it's almost like a pod breathing, infrastructure breathing, in and out, based on what your demand is for your workload. So to give you, a quick, just a level set about what vertical pod autoscaler is and what a horizontal pod autoscaler is, since those are the underlying mechanisms that we're talking about today. So Goldilocks creates VPA objects for specified workloads. The VPA has three components. Usually there's a recommender, which is responsible for looking at current and past resource metrics and providing recommendations based on that information. There's the updater, which is responsible for looking at the existing pods and determining, whether or not those pods meet the recommendation from the recommender. And then there's an admission controller, which is responsible for essentially doing a mutating webhook for pods that are entering the cluster and making them match whatever the recommender says that the pod should be set to. Goldilocks only cares initially about the recommender. When Goldilocks is installed by default, it only uses the recommender, so it doesn't actually adjust your live workloads. It essentially provides a dashboard that will tell you what it thinks your workloads should be set to, and then you can go and change those. So it starts off trying to be as non-disruptive as possible. and just creates the VPA objects so that the VPA controller under the hood can take care of, the recommender can take care of providing that information for you. And then for horizontal pod auto scaling, so that scales workloads based on target utilization, and it scales workloads out horizontally by increasing the number of replicas or decreasing the number of replicas based on your targets that you set. And usually people will target CPU and memory as the resources that they want to scale off of, because those are pretty simple. They're built into the HPA. And they don't require much additional configuration. You can use external metrics with the HPA, but it does require installing a metrics adapter and some other things to make it work properly. And then once you've decided to use one particular external metrics adapter, you can only use one. There can only one can sit at that API endpoint. So you sort of have to decide who you're going to use it with, and that's it. Which is why a lot of people use Prometheus, because it gives you probably the biggest bang for your buck if you're doing open source and free stuff. So this was a sort of refresher on what VPA is and what the HPA is. And now I'm going to get out of my slide and we're going to go someplace a little more interesting, which is going to be my terminal. And if you can't see it, let me know, because I can't see you. And yeah, so I have a cluster here that I just spun up as a sort of demo cluster. And I've installed like the Emoji Vodo application just to have something to work with. And there's not much really running in this cluster at all. So we'll start with talking about Goldilocks. Okay. So we go to the Goldilocks namespace, and I've already installed it. And it's installed pretty easily using Helm. And there are a couple of prerequisites for installing Goldilocks. One is you need a metric server for aggregating the metrics that you get from the kubelet and making those available at the metrics.case.io API endpoint, which I have installed here. And you also need to install the VPA itself, which installs a number of CRDs that are used for making those recommendations and the other things that I talked about a little earlier. With the VPA, if you can install it from the upstream directly from the VPA repository, and I believe that installation, there's like a VPA up.sh script in there, will install all the components. If you install it using the Goldilocks subchart or the Fairwinds VPA chart directly, it will not install the updater. Right. And the updater, again, is the thing that will actively essentially eject pods when they don't meet the recommendation, and so that they can be recreated and go through the webhook and be changed to meet whatever the recommendation was. So again, by default, it does not actually change anything. It just gives you recommendations. So in this, if we go back to the Emoji Vodo namespace, and we look for VPAs here. So if I look for VPA, this is being a little slow, but you can see there's a bunch of VPAs for the Emoji Vodo app, and they're all set to off. So this is the update mode. It means that it's not going to update anything. It's just recommending stuff. And these are the suggestions from the VPA. And we can actually go into one of those in detail and just sort of have a look at what the spec looks like. And you can see there's a target ref where it's targeting the emoji deployment. And again, the update mode is set to off. So right away, we have recommendations coming in, and we have some data to work with. You might wonder, like, how do we get these VPAs created? Like, I didn't do anything other than install Goldilocks, right? Well, there are, I think, essentially like two ways to tell Goldilocks what to manage via VPA. One is you can label a namespace. So if I do this, if I look at this, the labels on the Emoji Voto namespace, you can see this label here is what you need to add to your namespaces to have Goldilocks pick it up and create VPAs. So it will create a VPA for anything that is deployed to that namespace by default. You can also, and I'm going to switch to a different cluster for this, just because we've installed it differently over here. Yeah, there we go. If I look at the Goldilocks controller deployment over here, you can also pass in this flag on by default equals true, which will install, which will essentially trigger VPAs for every namespace in your cluster. You can also, instead of using this, do an exclude list, or you can do an exclude list in addition to the on by default. If there are some that you don't want, to have VPAs created, you can also take this out and put in an include list and specify which namespaces you want to be used with VPA as well. And then what you get at the end is this handy dandy dashboard, which I'm going to cheat. I'm a big old cheater, and I prefer not to have to type too much if I don't have to. Oh, that's not the right one. I'm not in the right, sorry, not in the right namespace. And this should port forward for me. Now you can do this with an ingress as well. You don't have to do the service like I'm doing. And probably if you're making this available to your developers as part of your platform, you do want to expose this for them to be able to get to, because likely they won't actually have access to your cluster to be able to run those commands or anything like that. So they would come to this dashboard where all the namespaces that have VPAs enabled will be listed here. And if we click on the namespace, the sole namespace that I've enabled this for, you can see that it provides you with information about what VPA recommends for CPU requests and limits and memory requests and limits, both in the case of guaranteed QoS and burstable QoS. And provides a YAML snippet down here that one can copy and paste into your manifest. So, if you're a dev and you keep having pods crash and it's because of memory, usually I would say 90% of the time when I see people deploy things for the first time to a cluster, they don't really have, they haven't done a lot of a benchmarking, right? So it's a guess how much resources your application needs. And people either skew to too little or they skew to too much. Too little obviously causes crashing. Too much causes inefficiency, and it can cost you more because you have more nodes you have to spin up and a lot of unused resources. So this is a very good starting point to copy this into your manifest based on the information the VPA has, and then adjust it as you know, right? Because the VPA doesn't know your application as well as you do, obviously, and there's a limit to how much data it has. By default, it uses the metric server and it uses some checkpoints that it creates for historical data. You can also plumb it into Prometheus and have longer historical data, which is used for the initial recommendation. But if you are a web business or you sell wreaths, then probably wintertime holiday is going to be a huge spike in your application, in your load that's not necessarily going to be captured and seen by the VPA, right? And so that could cause some issues temporarily. Which is where the other side of the scaling comes in, which is a horizontal scaling. So you set your VPA, use the VPA to set, your sane requests and limits. And then outliers and things like that can be handled by something like horizontal auto scaling, which can scale your workload out in terms of the number of replicas. And that's where we come to talk about Keda, right? So Keda, I'm going to go into the namespace that I created over here. also ahead of time because I like to be prepared. So Keda installs a number of CRDs that are used to do the magic that it does. The one that we're going to really focus on, and that's most common to be used, is the scaled objects CRD. So Goldilocks creates VPA objects that the VPA uses. Keda uses scaled objects to inform the creation of HPA objects. And then the HPA itself actually takes over from there. Keda has three components. There's a scalar, and actually there's, let me go to, if I can really quickly, the Keda page, Keda scalars. So there's Keda has a list of scalars that all define how you can call it and how you can, trigger off of them and what sort of settings they take. And these scalars they watch the resource, or they watch the source that the scalar represents, and passes the information, the metrics from that source to the metrics adapter, which Keda has built in. And then the metrics adapter provides those metrics in a format that the HPA can understand, and provides it at the custom.metrics or external.metrics.kates.io API endpoint. So you can have a number of these metrics or these scalars defined, as opposed to, as I said before, being stuck with like one external metrics provider, because that's the only thing that you can only have one registered in the case of native HPA. If you're using Keda, Keda has its own metrics adapter that then plugs into all these various things. So you can scale on RabbitMQ and Prometheus and Azure and all these other things if you want to. So that's one of the really nice features of Keda. And then there's an operator that essentially takes a scaled object that you've created and creates HPAs based on your scaled object. So if we go back over to the terminal, I'm going to go over into my emoji Vodo. So we're not going to see anything too exciting in terms of demonstration, because the sandbox cluster is borked, but that's what sandbox is for. It's for breaking. And I did not get Prometheus installed and working in my test cluster. So let's just let's take a look at the scaled. Do we have any scaled objects? I don't think I created any. Right. Okay. So what I'm going to do is I'm going to create a sample scaled object in the emoji Vodo namespace, just to show you kind of how Keda works and what it does. So I have a file here called scaled object that has a spec, and the spec identifies the target. By default, if you just put in a name, it's going to look for a deployment of that name. And then triggers is where you define the source that you want it to scale from. And in my case, I used cron, because cron was just the easiest one for me to use as a demo. I don't see it over here, but I think I'm also using an old version of the docs. So there we go. Scalars. Yeah, there's a lot. I thought that looked like a very small amount of scalars based as opposed to what I'm used to. So there's a cron scalar. Here's a trigger spec. It's very simple. I just copy pasted this actually over. And here's a spec. So if I want to just do a quick demo of this, then I'll just change my start time. We'll say, what is it? 12. No, sorry, it's 1 now. So we'll say 13 o'clock to 13, I say 15, I think. And we'll ignore the fact that the comment doesn't apply anymore. So if I apply this scaled object YAML to the cluster, so now if we say get scaled objects, we should see the scaled objects created right here. The trigger is cron, and it's ready. Is it active? Ready went to unknown. No, demo goddess, don't do it. It's not what I want from you. Let me just make sure I actually put the right stuff in there. 13, 15, desired replicas 2. It is, in fact, 1 o'clock. Let's see. And if I look at pods, we are not scaling, or are we scaling? We did scale. Okay. So for some reason, I'm not sure why the scaled objects were showing unknown instead of, I was impatient. All right. So we have a scaled object that I created using that manifest. And that scaled object in turn created an HPA, which you can tell is managed by Keda because it's prefixed with Keda. And it essentially said that during this time of day, this like 10 minutes that I put in that spec, I need to have 2 replicas of my web pod. So that's a very static and not super dynamic example, but what we had or have going in our sandbox cluster is a little cooler. So if we look at get scaled objects over here in this other cluster, we have a lot of triggers that are running off. We have a lot of scaled objects that are running off of Prometheus triggers. We have an external trigger. And we actually have some add-ons that are in beta that we were testing out. So there are a lot of different and more dynamic ways that you can scale with Keda. This was just an example, just so you can see it in action. It's a lot cooler, honestly, when you're scaling off of something like Prometheus and you get to see it truly fluctuating up and down. And again, one of the neat things about Keda is that you can scale to 0. So if you are you have a developer platform and you want it to not have any pods running when no one's working on it, it can scale down based on, things like queue length, based on HTTP request. And it can also scale on something as simple as CPU and memory as well. So those are 2 tools that we use to bring some stability to our platforms, and that I think can be useful for mitigating some of the pain that comes along with resource contention and resource exhaustion when you're running in a shared environment. I believe that is the end of my talk. And I'm going to stop sharing my screen.
Hello.
I love that you're like, and I'm going to stop sharing my screen. Awesome. We have a question for you.
Okay.
I'm going to show it, which is, does Goldilocks currently provide a way to customize recommendation it shows or anything already on the roadmap? The specific use case I have in mind is to recommend our custom Carpenter node pools for workloads with particular behaviors to optimize things, cost, latency, etc.
So not that I know of. To recommend your custom Carpenter node pools. So that actually sounds like wanting to schedule pods on a particular set of nodes versus increasing the resources that the pods are using, unless I'm misunderstanding the question. But Carpenter is a cluster autoscaler. So it creates node pools, and you can put in a variety of different node types, and it will intelligently bin pack your workload on those. And so I don't think that those are like quite in alignment, right? Like the Carpenter is about increasing the number of nodes, and Goldilocks is about literally just vertically scaling, like increasing the size of your pod, so to speak? Let me know if I misunderstood that question.
Well, you also have had some great demo. So
Awesome.
Yeah, again, some shout outs. If anyone else has questions for Stevie, or if the question wasn't quite answered, just re-ask. Stevie can stick around for a little while, I'm hoping, and continue to answer questions. So if there's no other questions right now, then we will.
Thank you, Stevie.
Awesome.
Lovely to see you.
It was great to see you.
We'll
Bye.
talk soon.
Yes.
Yeah.